Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we'll continue our discussion with regard to integration. So what we're going to do today would be to discuss integration by parts. So integrations by parts. Let me just get the slides on the screen. Okay. So what is this integration by parts? So it is simply a technique for you to do integration. Okay. So far from the previous discussion on indefinite integral, with regard to if the integrand or the function is a natural log function, for example, in this case, natural log of x, so far none of the formulas, none of the techniques that we considered can be used to find the antiderivative for the natural log of x. Now, the technique, this technique, integration by parts, will enable us to find the integral of the natural log of x and many other integrals. So integration by parts, okay, is basically based on the product formula. Okay, the product formula for derivative, which states that if f and g are two differentiable functions, then the derivative of this product would simply be a combination of the original function f with the derivative of g plus the original function g multiplied with the derivative of f. Okay, this is what we have discussed so far, and this is basically the basis of integration by parts. Now, integrating both sides of the derivative of a product formula. So, if you recall, if we have when we want to do the we can rearrange, right? I mean, this is the combination, the product of these two function f and g. So we have this. So we can rearrange. So what we are doing here is we simply gonna bring this this term. Okay, we're gonna leave it here, and we're gonna bring this to this side. Okay, so we're gonna have f and g prime would equal to the derivative of the product minus the original function g multiplied with f prime of x. Okay, so this is the what we have done. We simply moved gx f prime x to the other side. Okay, now from here, okay, we're gonna integrate the whole equation. So when we integrate both sides, what we are doing is this. Okay, so now take note of this term, the right hand side, the first term here. So what happened when we integrate this? I mean, this is the derivative of this product, and then we integrate it. So we are actually, so this would cancels out the integration, and this basically gonna leave us with the original function itself. So from here, we're gonna have this. Okay. Now this thing gonna cancels each other, right? I mean, this is the derivative, and then we are taking the antiderivative. So we're gonna get fxgx, f and g, the original function, and we are left with this equation. Okay, this equation. So this integral equation can be transformed to a more convenient form. We can make it more simple if we can redefine some of the terms here. If we can redefine f of x to be u and g of x to be v. So du would then equals to f prime x dx, and dv would equals to g prime x dx. So we can rewrite. So this is what we got earlier after we integrated both sides, okay, of the product formula. So we want to transform. So this would be f of x would be u, and g would be v. Okay, g would be v. So now when we are doing this, so g prime, so we're going to basically redefine some other components here. F prime dx, this would be du, and since this is g, v is g, so g prime dx would be d of v. Okay, so this is the integration by parts formula, where we have simplified, okay, this equation to be the integral of u dv equals uv minus the integral of v du. Okay, so this would be the formula. So let's do few examples. Okay, Now, don't worry. The integration by parts is simply a technique to make the integration easier. It's just that because sometimes it is not directly clear, or it's a bit complicated to identify the pattern. When you find it complicated, so you can always use integration by parts. So let's say we have this x exponent to the power of x to be the function. Okay. Now let's use the integration by parts, and then we need to check the results. Okay, we need to check the results. So let's say, so previously we know that what was the formula? So it's the integral of u, okay, dv equals u multiply with v minus the integral of v du. Okay, so now we're gonna have to define, okay, some of this. So we're gonna redefine. So let's define now this would be in this format. Okay, we want to basically change this into this. Okay, we want to change this into this. So what we're going to do is that we're going to define. So we have u. So let u to be u equals x, and our dv would equals this whole thing, e to the power of x and dx, because we want to rewrite this whole thing in this format. Okay, so what is our du now? So du would be, well, if we were to differentiate this, okay, so we're gonna get du gonna be dx, and v would equals to, we have to integrate this, right? So we're gonna basically integrate this in order to get v. So we simply need to integrate ex dx. Okay, ex dx. And what is this? So apply the formula. We can apply the formula for exponent. So this is simply ex. V equals to ex, right? I mean, the derivative as well as the antiderivative of exponent function would be the exponent itself, because this is simply x. And at the moment, we can ignore the constant, because we can simply add the constant at the final step, at the one step before the final answer. Okay, so now we can rewrite this problem in this format. Okay, in the integration by parts. Okay, so so if we were to rewrite this, we're gonna basically, it's gonna be u dv, right? Our u dv would be, yeah, we have already basically rewritten all this, right? So have managed to have this, and we have rewritten this. So let me just try to collect all this information. So we have x, ex, okay, dx would then equal to u multiply with v. So u is x, and then multiply with v. V is e to the power of x, and then I have the minus sign, and then the integral v du. So v du. So my v is e to the power of x, and my du is dx. Okay, so to do this, we can integrate this by parts. It's called integrate by part because we have separated the equation, the original problem, into two parts. So I'm going to have the first term here as it is, and now we can integrate this, right? It will be very simple. So the integration of this e to the power of x would give us e to the power of x itself. Okay, and don't forget the constant. And this would be the answer. See, I mean, rather than doing this problem directly, it will be much simpler to do it by parts. Okay, so this is the first example. Okay, the first example, just that don't forget to put in plus C. Okay, then to check, okay, to check the answer that we have obtained. So if we were to differentiate this, we will get the original function. Okay, so this is you have to apply the product rule here, right? I mean, x So this is the answer here. So we have, so x, and then differentiate d of dx e to the power of x plus, okay, e to the power of x dx over dx, right? And then plus d over dx of c, right? I mean, this is a application of the product rule. So we have ex multiply with ex, okay. I missed this. So there is another e here. So when you differentiate this, d of dx e to the power of x. This is the second e, okay, this one. So we have x e to the power of x plus e to the power of x. This is 0 minus e to the power of x. So we are left with x e to the power of x. Okay, I mean, always, if you are not sure, always try to check your answer. Second example, so in this form, so let's just rewrite. So what is the formula again? U dv equals u multiplied with v minus the integral of v du. So we have to first of all define, okay, all these terms that we have in the formula by using the information given in the equation. So here, let's define u to be the natural log of x. Okay, so this is u. So du would then be 1 over x. Okay, dx. Okay, 1 over x dx. And this is dv. So dv, since I have defined natural log of x to be u, so my dv would be x multiplied with dx. Okay, x multiplied with dx. So in order to obtain v, I have to integrate this, and I will get x square over 2, right? Because from dv is taken from this equation, okay, from the original equation, and we can obtain v by integrating it, by integrating the dv, okay, to obtain v. Okay, so now we can rewrite the whole equation. Okay, we can rewrite the whole equation in this format. So it will be, so what will it be? So x natural log of x dx would then equal to uv. So u is natural log of x multiplied with v, which is x squared over 2 minus, okay, now we have to put here x square over 2 with a du. So 1 over x dx. Okay, so then try to simplify this. Okay, when you open the equation, so this is natural log of x multiplied with x squared over 2. So this is the answer here. And this would be, when we integrate this, okay, we can cancel this out, right? We can cancel this out. So this would basically be, so from here, I mean, this, let me just try to do it over here. So this one become x squared over 2 natural log of x. And now if we were to simplify this, I can cancel this out. This would be x over 2 dx. And this would be x squared over 2 natural log of x minus, so this is half, I mean, you can take it out. So this become x to the power of 2 over, this is already over 2, and then we have to divide with 2, right? So 2 multiplied by 2 is 4. Okay, and then don't forget c. That's how we get this, and this is the answer for example 2. Okay, so try to differentiate this and make sure that you should be able to retrieve the original equation, this one, the original function. Okay, so this would be the summary to do the integration by part. Okay, so first of all, you need to redefine the product, okay, u dv, okay, by replacing the original terms in the original function with this term u and dv. And then it must be possible to integrate dv, because dv, from dv you need to integrate dv in order to get v, okay, because later on we need to have v. here and here. Okay, and then the new integral, okay, of u dv should not be more complicated than the original integral. This part, the right hand side, must be more simple compared to the left hand side. I mean, otherwise it defeats the purpose of doing the integration by part. Okay, maybe if you can do this directly, why bother yourself to do the integration by part? For the integrals involving x to the power of p and e to the power of ax, okay, so the hint is that try to make u to be equal to the function with the base x. Okay, try to always define u to be equal to the term that has the base x rather than having x in the power, okay, in the exponential power. For integrals involving the product of this x and the natural log, so always try to define u to be the natural log. Okay, the natural log. Okay, I mean these are all just the first and trial and error. If this doesn't work, then you have to change. Maybe you want to use u to equal to e to the power of ax, or here u equals to x to the power of p. Okay, but usually this would be the hint, the suggestion. Um, this example basically it require you to do the integration by part two times, because when you do it for the first time, if you look here, okay, the second term here, okay, it is still complicated. It is still complicated, like this term. It is still complicated. This is a product of x, a number that is with the base of x and an exponent. So that's why you need to again focus on the second term. This is from the second term, and you do another integration by parts. Okay, integration by parts. So don't forget to substitute it back. Okay, to substitute the answer that you obtain here back here. Okay, so this one basically you need to do the integration by parts twice, two times. Okay, if you are not sure, just check. Okay, I think I'm going to leave example 4 to your own exploration. Okay, because it also shows how the region, okay, under the curve, okay, is shown there on the slides. And I think that's all for now. So if you have the time, I would really strongly advise you to do some exercise questions with regard to integration by parts. So just make sure you have to memorize the formula, and make sure you define each of the term correctly. What is the value of u, and then what is du, and then what is dv, and try to integrate dv in order to obtain v, and then plug the values in their right position according to the formula, and then try to solve the integration. Okay, it's just that sometimes you may find it more complicated and whatnot. You may want to redefine, you may want to change the term that you use to define your u and your dv. Okay, so that's all for now. Thank you. Assalamualaikum warahmatullahi wabarakatuh.